Hey everybody, welcome back to EE368 Signals and Systems Laboratory at Cal Poly. My name is RJ and today I'll be presenting a Simulink demo to get you started on your first lab experiment. So go ahead and share my screen. So before we get started, we want to make sure that we have the Simscape Electrical toolbox installed. So to do so, you can click on add-ons from the MATLAB editor and search for Simscape Electrical. And if it's installed, you will see this green flag saying that it is installed. But if not, you can go ahead and click on here and run through an installation process. So with that installed, we can go ahead and click on Simulink, create a blank model, and we're going to save this as Simulink demo.slx. All right. So first things first, we can double click the white space and create an annotation. I'm going to be creating a low pass filter. So we can make a annotation so that we know what is being displayed here. And the first source that we're gonna, the first block that we're gonna want to use is an AC voltage source. Blow this up a little. And let's say we want to look at a 10 volts peak to peak. So that's gonna be a 5-volt peak at 100 hertz signal. And you can get to this properties page by double clicking on your component. The next item we're going to want is a resistor, but we don't want to use these resistors. We're going to want to use a branch. So an RLC, either series or parallel branch. And we can double click this and change this to just a resistor. And let's say we want 150 kilo ohm. So that's 150 e to the 3. So there we have our resistor. And we can get a capacitor similarly from the RLC branch. Double click this, change the branch type to capacitor. And let's say we want a capacitance of 10 nanofarads, so 10 e to the minus 9. All right. On Mac, you can rotate this RLC branch by pressing Command R. I think on Windows, it's going to be just Control R. And we can go ahead and wire up our RC low pass filter. All right, so from here, we're going to want a reference. So get ground from this power system utilities, expand this and connection. This is going to be our reference. And now we want to measure the output voltage across this capacitor and the input voltage across the source. So we need a voltage measurement box. And we can connect this positive end here and the negative end here. And another voltage measurement. And we can move this. Let's move this annotation to here. So this plus is going to be the output of voltage source, and then minus is ground. Okay. Now we can get our oscilloscope. This is going to be called a scope block. And we can connect channel 1 to the input and the output to channel 2. And here we have our circuit wired up and ready to analyze. So knowing that the frequency is 100 hertz, we can change our stop time to 1 by 100. And it'll automatically calculate that for you. So you can just go up here, type in 1 divided by 100 and run. And of course, we need our power GUI. This just allows the oscilloscope to run properly. So run this. And then we can open up our oscilloscope by double clicking it. And here we have the signal. So we can go to Tools, Measurement, and Peak Finder to look at the peaks of our voltages. So one thing that I also like to do is double click on this, change this to be in, and double click on this to be V out. be out, so that when we run this, there's no ambiguity in what signal is where. So this yellow signal here is our input, and it has a peak of 4.99, about 5. So we can also change the trace to the output by clicking here, and we can see the output has a peak at about 3.632. And with that, we can easily determine the magnitude of our transfer function. So another interesting measurement that we can use for the first experiment is the cursor measurements. So if we pull this up a little more, we can analyze the phase delay by moving this first cursor to around the peak of the input signal, and then move the second cursor to the peak of the second, about here. And right here, we see that we have a delta t time delay of 1.288 milliseconds. And with that, I think you have everything that you need to do portions of the first experiment. On the next video, I'll go ahead and run through an example of how you can simulate an arbitrary transfer function using Simulink. Hope to see you in the next video.